Dear students, how are you? Today we are going to discuss very short question of unit 2nd, our subject physics. First question. How does the drift velocity of electron in a metallic conductor vary with the increase in temperature? Sir, what is drift velocity? The minimum velocity which is acquired inside a metallic conductor when there is a potential difference is applied across it. If we increase the temperature, means collision are going to increase, then the drift velocity, by increasing the temperature, the drift velocity decreases. Because there are more and more collisions are there. Question second. A copper wire of resistivity rho is stressed, so its diameter reduced half of its previous value. What will be its new resistivity? It's a clear thing that resistivity of a particular material is the characteristic property of that material. It depends on the material only. If you are stretching, reducing, then there is no change. So its resistivity remains same, that is not going to change. Does drift velocity vary with the magnitude of the current through the conductor? We know this formula. The current flowing through the conductor is I is equal to NEA VD. Means VD is equal to I upon NEA. If I increases, a current increase kariye, what happens? Then drift velocity also increases. Question 4. If the temperature of good conductor increases, how does the relaxation time of a conductor change? What is relaxation time? It is the collision of the free electron between two successive collisions. The time taken by a free electron between two successive collisions is called relaxation time, and the distance is mean free path. How the tau is vary? Tau is vary m upon n e square rho. What we are doing? We are increasing temperature. We are increasing the temperature. Temperature increases. Rho is the resistivity. Resistivity depends on the temperature, so resistivity increases. If the resistivity increases, the tau is the reciprocal of resistivity, so tau decreases. Next question. Can Kirchhoff law be applied to both direct current and alternating current? Yes, Kirchhoff law we can apply to DC and AC circuit both. Yes. Next question. Why Wheatstone bridge method for measuring the resistance more accurate than the other method? Sir, what is the Wheatstone bridge? It is a combination of four resistance which are arranged as the four arms of a parallelogram. Right? PQRS. It is a null method. In this null method, there is no current flowing through the galvanometer. Right? Why? What is it? Is null position method. Null position method means when there is no current flowing through the galvanometer, means our bridge is balanced, then we can use this equation P upon Q is equal to R upon S for calculating the unknown resistance. Next question. Does EMF represent force? No. No, sir. EMF does not represent force. What is EMF? EMF is meaning is electromotive force. It's a work done per unit charge in flowing through a closed circuit. So EMF, what the unit of EMF is? Volt. So EMF is not force, it is simply work done per unit charge flowing inside the conductor. Sorry, in a circuit. So, but dear students, we're trying to complete your very short question up to Unit 9 positively, and hope so.